So that's mean the probability for rain. For the rain is about 0.25, or you can say 25% if you want to. Notice also 0.25, you can also express it into 1/4 as well as a fraction. So another word I can say probability of, I can usually the P like this and put R for n. Okay, that's gonna be probability, or I give it as probability for n or probability of R. I can say probability. We use R for n. Wow, one moment. Get my pen again, erase that little part here. So probability for the rain, that'll be 0.25. Okay, notice that this can also be written as 1/4. This also can be written as 25%. So whenever you talk about probability, expects to have something expressed into either in a decimal form. Expect something like that. It can be either the decimal form, either into a fraction form. This is called a fraction from 1033, or either in a percentage form. Most of us understand very well percentage, because it gives us, you have more meaning for us. Whenever I say 25% of rain today, that's mean any amount of rain. We understand that idea, that concept better. Okay, compared to say 0.25, which is a decimal, kind of like hard to understand. But the idea of percentage is more into our blood. We understand that one very well. Okay, so whenever talking about probability, expect that a number to be either a decimal number, a fraction, or percentage. These are the properties I would like to talk about probability. I have 2 pages for probabilities. Okay, first of all, the probability, whatever the event. First, let me just go back again. I probably forgot to say that word. So in this case, R also is called an event. Okay, the event we're talking about is about the rain. Okay, that's the event. Okay, so this is an event. Now, this is what we say about. So whenever we talk about probabilities, it's always a number between 0 and 1 inclusive. It cannot be more than 1, it cannot be less than 0. Okay. If the probability of an event B is equal to 0, it means that event is impossible. Give me one moment, please. Yeah, the probability that event will be impossible. You can say impossible like this. Okay. It like something that's impossible. For example, we can say probability to have Christmas. Probability of Christmas is put let's just say, let's just do that. Let's just put that instead. Let's just say given the event A, we can say, suppose the event C, let's put C, is having Christmas you can say having Christmas and July. So as you can see, probability of C, that's impossible. You can say that'll be 0. Okay. And now there's another one. You can say probability, for example, if probability of, for example, uneven W is equal to 1, that means this is certain to occur. Okay. Suppose I say probability, suppose that W is the sunrise. Sunrise tomorrow. What's the probability of a sunrise tomorrow morning? That's whether you like it or not, whether we want it or not, there'll be a sunrise tomorrow. Okay, whether you're gonna be here or not, there'll be a sunrise. So that means this is certain to occur. But notice that probability is always going to be between 0 and 1 inclusive. Okay, so if something is unusual, something that's unusual, the probability will be about less than equal to 0.05. Okay, suppose I go on the streets, somebody asks me when were you born, and then ask somebody. I say to somebody, when were you born? That person gonna say, doesn't expect me to know the answer. Not everywhere you go, we expect somebody to also know your social security number. So if the person was able to guess your social security number, the probability for that is very unusual. Okay, or even to guess your age is very unusual. So to guess somebody's age, if we think about somebody's age, let's put age for somebody. Notice that you are born only one day out of 265. You are born only one out of 265. That number is way less than 0.05. Can somebody find it for me? To get the day you were born. Now I didn't mean age. I meant the day you were born. That's what I have in my mind, and I put age. So let's put birthday. Somebody gets a birthday just like that at random. That's gonna be 1 out of 265. They're kind of impossible. Close to impossible. Anybody can do 1 out of 265, how much it gives you? 1 divided by 265, how much is that? You are born only one day. You are born only one day out of the year. Only one day you were born. Everybody was born exactly one day out of the year. You're gonna be born in 2 days. You're gonna be born in 5 days. Thank you. So the probability for that is gonna be 0.003. See, that number is less than 0.05. That's mean this is very unusual for somebody to guess your birthday, just like that. If the person was able to guess your birthday, maybe is a pure luck, or at the same time, that person is a cook, or somebody wanna see, maybe somebody wanna steal your information. So remember that. That's important. It kind of like quite close to unusual for somebody to guess the day you were born just like that. Okay, unless you give it away. If you don't give it away, so it's gonna be hard for somebody to guess the day you were born. Okay, so notice that probability can never be negative. Okay, you can also say 0% or 0. You can say 100% or 1. It's the same thing, but it cannot be negative. You can always want to be positive. It cannot be more than 100%. For our class, we're not gonna have probability that is like 120%, 110%, or like 3, probability of 3. That's impossible for this class. The highest one you can have is 1 or 100%. Okay, there's something called complement of probability. Let me talk to you about it quickly. So suppose I say the probability for rain today is 25%. Okay, so probability of rain, suppose A is the event of rain. Okay, A with the letter C right here, it means no ring. That's called the complement. Another term for A, you can say, you can read as A complement. Okay, so if A is ring, that means AC will be no ring. We have another way to express AC. Some people in some books they use the term A prime, like this too. That's you can also use this term as well too, A prime. Okay, so you can also use this term. Some other book also like to use the expression A bar. Okay, they use sometimes A bar. Just in case you get into it, it means the complement. So that's mean, what is the probability of no ring? Okay, suppose the ring was 25, the probability of A was 25%. Okay, the whole is 100%. That's mean the probability of AC will be the opposite, like 75%, enough to get 100%. You guys you understand? So this is what you get together. That's mean the whole will be 100%. Remember, we're gonna be more than 100%. So probability of AC, which is the opposite, which is like no ring, the complement of A, that'll be 75%. Another way to do it, you can also do 1 take away 0.25. That's gonna give you 0.75. Okay. So I say AC is the complement of A means that A does not occur. That's when A does not occur. If there's a 25% of winning something or win something like that, there's 75% of chance of not winning. Okay. Any questions so far? Okay. Now, it's not about probability of equally likely events. This is the definition for probability. Okay. So earlier we talked about something like this, probability of something like that. What was it again we talked about earlier with the 25%? Oh, with probability of win. Okay. So we did say that it was going to be like 1/4, something like that. Okay, that's the definition. A will be that number of A, the number of ways, it can be number of ways or number of clouds that are the way R can occur or can happen. Okay, that's mean out of 4 ways, then there's one chance for win. Okay, out of 4 ways, there's one chance for win. Okay, so this might not make a big sense to you, but I'm going to use a different type of example so you can see what I'm talking about. That's mean out of 4 ways, that's one chance. This is the definition for probability. So it means that number of way, number of outcome, and A, number of all outcome of all possible outcomes. That's what the definition. Okay, you can just keep it and try to understand and read it on your own. Okay. So that's just the definition of that. We're talking about the example in which we talk about some cards. Say this one say find the probability of picking an ace. Okay, form 52 cards deck. Do I have a picture of a deck here? So let me see. I just point a picture from online to make sure to give an idea of what I'm talking about. Notice that we have the ace are here. So let me see. 1, 2, 3, 4, 5. The card is a bit too small. Okay. So we usually have 4 aces. Again, you got 52 cards here. Okay, 1, 2, 3, that's 10, 12, 13. That's beyond 50. The ace will be the one on top. This can be the ace right here. Okay, we got 4 aces. So this one is this ace for the heart. Okay, you got this one, that one, that one, that one. And then we have a total of 52 cards. Okay, we got a total of 52 cards. Out of the 52 cards, if you have the 52 cards, well, we can see how many of them are ace. It's just gonna be 4 of them. So we're gonna say X B4. Okay, let me double check the question one more time so I make the right decision. Okay, so right here. So just like you say, find the probability of picking an ace from 52 cards. Because you have 52 cards in total, then 4 of them are ace. Okay, then it can become like 1/13. Here we express the probability in terms of fraction here. So express something like that sometime. It can be fractions, it can be decimals, or it can be percentage. Okay, so now this is what we have. Any questions? Let me see. Somebody said no question? I can't even see the time very well. Okay, so no questions. All right, then. There's something else I want to talk about here. This is just the definition of probability. That means don't think the probability is just going to stick only with the range. Okay, it's going to be more than that. So we can apply to so many concepts that are going to be more. I mean, while I will go, you're going to see that it makes a lot of sense about that definition. So this is going to be our main definition for now. So you don't have to memorize it, but remember that to get a probability is just a number over another number. It's like a fraction. So remember fraction whenever I talk about fractions most of the time, okay? So here, this is another example here. You say to roll a dice. A dice it has the following thing. It is something like this. That's a dice. Okay. So in the dice, you got 6 spaces. Probably some of you already know that. It's like a complete cube. Okay, you got 1 over here, then 2 over there, then 3 over there, then 4 on the one side, then etc. All these 6 spaces. So I can just represent the faces right here for you. It can be like 1, 2, 3, 4, 5, and then 6. Okay, let's just put this is 1, this is 2, this is 3. Okay, this is 4. I lost my cursor. Tell me if you cannot see very well so I can make it bigger. I don't know. This is 5. Something like that. Okay, I cannot make it, but and the other one is just 6. Okay, so this is what I present the first for here. Now they're saying to roll a dice and find the sum whenever the sum is 6. Okay, so how do we do that? What do we get the sum to be 6? Notice something that if I got the first card, this is 1, okay, right? So let me do the sum of 6. So let's do that instead. Here, it just show like a table that gives you an idea of what we're trying to expect. Okay. So anytime you can have 6. If you do, because remember, you're gonna roll the dice twice. Okay, twice. Okay, that means if you have 5 and 1, will give you 6. Okay, this is whenever you do the first trial. Then also 2 and 4 will give you 6. So we're gonna know whatever it gives you 6. So we're gonna cut how many of them, how many of options we have here. Okay, so this is whenever you roll the dice the first time, because you got 2 dice. Okay, this is 2 of them. I'm gonna draw one for you. This is this one right here, and then there's another one there. This is dice number 2, for example, and then we have dice number 1 right here. Okay, so you want the sum, whenever you fold them, you want the sum to give you 6. This is the idea behind it. Whenever you roll them, this is what you have. You have, for example, one of them will show the face of 3, for example. Let's put 2. And the other one will show the face of 4. This gives you 6. Okay? This gives you 6. That's what I'm trying to understand. So we got 2 dice, and then we want to have the sum of 6. Okay? So I'm trying to focus on the face on the, I'm talking about the face. That's why I didn't try the other one. That's the face. So how many times do you have here? So we got 1 case, 5 and 1, 2 and 4, 3 and 3, 4 and 2, and 5 and 1 again. This gives you a total of 5 options. Okay, we got 5 options. Like in which case you're gonna have 6. Okay, but remember we got 2 cards. I'm sorry, we got 2 dice. All right. So because you got 2 dice, so the number of possibilities will be n. That give you 36. Okay. The reason I give you 36, if you fill out let me just erase that so you can see what I'm talking about. If you fill out the box, you're gonna have six options in total. And which like this one is like 1 and 1. We don't want that. You got 1 and 2, 1 and 3, 1 and 4. That 1 and 5, 1 and 6, and then you fill out the box. That this is 6 and 1, 6 and 5, 6 and 4, 6 and 3, 6 and 2, 6 and 1. So if you fill out this one, like for example, here will be 4 and 4. Everything together, it gives you about 36 because you got 2 dice. Okay, so how do you get the 36? Because you got 2 dice, right? You can just say this is 6 times 6. Just multiply them. I can say 6, and then you got 2 dice. That's gonna give you 36 options. That's how we got the 36. Okay, or you can just do it visually. So that's mean what we have now, the number of possibility will be 36 in total. Okay, so probably to have a sum of 6 each time, if you count them, that's gonna be 5 out of 36. Any question for that? Yeah, something you want me to repeat? Does anybody want me to repeat that, or what you find? Because what happened, we're not gonna have a specific case each time. It's gonna change. I know this is probabilities. I know I started with an example on which I talk about the rain, which kind of like very easy. Incidentally, I had to do something else. Okay, so it's gonna be you have to leave your spirit open. So you don't need you don't say with one thing exactly. Okay, so you're gonna have to find ways to understand the idea behind it. For example, this one say you have to put yourself in the shoes. That's why I showed the graph. You roll 2 dice, okay? Then you got 36 options in total. Not all of them give you 6. Okay, so you got two, you got, for example, you got 2, 1 right here. That's been 2 and 1, 2 and 2, etc. Go all the way to there. Not all of them give you 6. The only one that gonna give you 6 is just 5 of them. Okay, 5 of them. These are the 5 that's gonna just give you 6. You got 5 and 1 right here. You got 4 and 2. You got 3 and 3. And you got 2 and 4. And then 1 and 5. That's it. These five options, these are the only one time the sum of the 2 dice, the face value, the face that got stay up, give you 6. Okay, we're talking about the top face whenever you hold them. Okay. Now let's keep working. See that nobody have any questions. Now let's talk about something called n. So the probability n means whenever you see n between 2 expressions, this is like for combined probability. It means both of them can occur at the same time. Okay. So an example is, say if you roll a die, find the probability that it is even and less than. If you roll a die, find the probability that it is even and less than 5. Okay. This one, notice that we're gonna roll only one die. Okay, you roll a die. This is only one die here. Okay, so if I'm rolling only one die, that's mean n, my n will be just 6 because I only have one die. Okay, that my x will be 6, just one for one die. Okay, so my answer will be just 6 because just one die. So then what I want to know, we need to find the probability that is even and less than 5. So if you look carefully here, let me just go back to the previous slide. Let's go back to the previous slide. Notice that when do we have even values? Let's count them. 2 is even, that's 1 so far. 4 is even, okay, that's 2 so far. 6 is even, that's 3 so far. Okay. But the things that they say that it has to be even and less than 5. So because you have to be even and less than 5, we cannot take 6. So that's mean even though 6 is even, cannot take because you have to be less than 5. So only option we have is only 2 options out of 6. Okay, so let's go back here. So I'm gonna say the probability that is even and less than 5. So I would say, suppose I call this even and less than 5. Suppose I call this even W. I would say P of W is going to be equal to 2 out of 6. Okay, this is not simplified. So I need to simplify it. That's going to give you 1/3. What does that mean? Out of 6 possibilities, I only observe 2 that are even and less than 5. Okay, that's mean the probability just to be 1/3. Or I can just make it this one right here. So the die roll that are both even and less than 5 are 2 and 4. Okay, they are even, they are 2 even numbers and also less than 5. Okay, so you do that, probably even and less than 5, that'd be 2 over 6 and 1/3. So as you can see, the term and imply both of them. Okay, both units. Any questions? Now, this is what I'm going to be doing now. So I'm going to introduce you to a different type of thing. Wow. What did I just do? Did I lose somebody? No. Okay. Let's talk about something else, something called OR. We just talk about N right here. For OR, this is how it goes. You can also have probability of or A or B. Earlier, we are just by a probability of A. That means there's a formula we use for it. Okay, it's going to be the probability of A plus the probability of B Take away the probability of A and B. I just spoke to about A and B earlier. Whenever I look over here, this is even A and B, or you can say probability of A and B if you want to, in which A would be the even values, and B will be, means less than 5, anything less than 5. Okay, so the end is there. That means they occur, both must occur. Now the probability of all, it means that A occur or B occur or simultaneously, or they happen at the same time. Okay, I'm going to take the, I'm going to give the definition after, but I just wanted to choose the formula. It's just called equals like this: P or A or B, then we P of A plus P of B minus P of A and B. I would also put it back again for you so you can see. Okay, so what is that thing for? So the or is the probability means at least one of the events must occur. That means A can occur or B can occur or both of them happen. That's what it means. Okay. Here we'll give an example. So say find the probability of picking a spade or king from 52 card deck. Let's do that. We're gonna take a spade or king. So let's see. I'm gonna go to my cards right here. So let's see. The last column are the kings. Right here. These are the kings. Okay. So as you can see, we have 4 kings. Now the spade, how many spades do we have? We got heart on top, we got 12, and then probably this is the spade right here. Which one is the spade again? Diamond, and this is a spade. Spade, we have about 13 cards. Okay, so we're gonna do probability. They say probability of either is spade or king. Okay, this probability of either is spade or king. So how do we do that? So you got another way to do it. So if you do together, you can count them together. Let's count them together. I can do that as well. Let me use a different color. I can do the following. I can say, because it happened at the same time. Let me use a different color. Which one can I use? Red. I can say this is 1, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, no. Yeah, 11, 12, 13, 14, 15, 16. That's, we got 16 of them in total. So I would say 16 out of, because you have a total of 52 cards here. Out of 52. Then you do the math. Okay, yeah, you need to be simplified to work it out. Okay, so if you do the math, you divide by 4, that'll be 4 divided by 4 here, divided by 4 over there. That's going to give you 4 times 3 is 12. That's mean 13. Okay, this is the real value here. Or there's another way to do it. Okay, I can say using the formula, I can say probability of S or K is going to be probability of S plus the probability of K, take away the probability of S and K. So I'm going to say, how many S do I have? I have 13 S out of 52 cards. How many kings do I have? I have 4 kings out of 52 cards. How many king spade do we have? You only have 1 king, that is the king of spade. Okay, you cannot have 2 kings. So you only have 1 king, that is the king of spade. Again, BW1 out of 52 cards is the king of spades. If you do the math, that's going to give you out of 52, you're going to say 13 plus 4, take away 1. 13 plus 4, 13 plus 4, take away 1. That's going to give you 16 out of 52. I know you say that, oh, this is this is like harder to do that way. The reason you look harder to do that because you got the graph in front of you. In some examples, we're not going to have the graph in front of us. In some example, you're going to have just the numbers. So you're going to figure out how to do it, okay? Using either the formula. If you have some concrete example in front of you, then you can just go out and count. Because it says spade or king, just count them. How many you have together? Okay, here you got 16 that are both spade and king at the same time. No, I'm sorry, not the same time. 16 that are together, combined 16 of spade and king, not at the same time. My mistake. So that's either you have spade, or you have king, or you have the king of spade. Okay. So let's look at a quick definition here. That's something that is also mutually exclusive. By the way, any questions about that before I continue? Any questions? Okay, no questions. Now we're going to talk about something called mutually exclusive. This will happen whenever two events are mutually exclusive. That means they cannot occur at the same time. If they cannot occur at the same time, you're going to say it's mutually exclusive, and the probability of both of them to happen at the same time will be 0. That's the probability of A and B will be 0. Whenever that probability of something that's impossible will be 0. Okay? Probability of that's impossible will be always 0. Okay? So this is an example. Before I do that example here, okay, yeah, I can just talk about it. Can you be at the same time? Can you select a person that is both Republican and Democrat at the same time? When you select a person who is Republican and Democrat at the same time, is that possible? One person who is Republican and Democrat at the same time. That means in their electoral vote card, you say, I'm both a Republican and a Democrat. Is that possible?
No.
That's impossible. If it's not possible, the probability of such event will always be 0. Okay, you can have somebody that is both Republican and Democrat at the same time. That's why I say right here in this example there, you say that a person is selected at one person. You see, a person, not two persons. A person is selected at random. A person. Okay, let A be that the event that the person is a registered Democrat, and let B that the event that the person is a registered Republican. For example, you just put B for that. So A and B are mutually exclusive events because that same person cannot be both Republican and Democrat at the same time. This is mutually exclusive. That's the probability of A and B would be 0. Okay. So B is you are Republican, and A will be that you are a Democrat. So if you put them together, that's impossible. That would be 0. So let me remind the rules again. So this is the first one we saw today. Probability of AC is equal to 1 minus P of A. We also talk about this one, probability of A or B is going to be P of A plus P of B, take out P of A and B. This is for the OR. Remember it. We also talk about mutually exclusive. But this is what happened. Whenever it's mutually exclusive, you don't have the second part because P of A and B will be 0. This is what you have. Okay, this is the new way to put the probability of A or B. If you are mutually exclusive because P of A and B is equal to 0. Okay, These are some formula we saw. Make sure you write this formula in your notes whenever you have to take the exam. And I would suggest you also to print, just in case, to print. If I don't have it, I'm pretty sure I have something online, but to print a 52 card deck, you can just print it from online, okay? Or you can just print the one that I have here, make it a bit bigger, and use it, because I just copy one and put it in the system, okay? So usually when I teach, I don't use the same thing I used before. I just start from fresh. So like I'm doing something new. So I don't do them before, okay? So just like I'm doing something new, that's what I like to do, okay? So so make sure you can print something online for the tech card so you can use on the exam, all right? This is what I want to point out to you again. And the exam, I don't really want you to, I think it's best for you to be able to use more, because this is gonna be more than what we have earlier in the first set of this class. So this one, I think for the next exam that's gonna come, because I'm gonna talk about a lot of stuff, it's best for you to use like anything that you know. I have notes on the side, okay? And then not only 2 notes, but more than 1 note, okay? Because the exam's gonna be like kind of like a little bit more challenging, because you're kind of in the middle right now, okay? Now we use, I just show you an example of the 52 deck card that we use as visual representation. You know, so when I was doing when I was talking about the dice, I'll show you 2 dice, and I'll give you a small table to give you an idea of how it look like. There are some other graph that we use, something called Venn diagram. Here, for example, if we look at the picture that we see right here, you got some people who have no hats, some people with glasses, and some people with hats, stuff like that. So I can create something called a Venn diagram that look like this. And I can say hat and glasses. So these are their names, okay? Notice that about 2 people have hat and glasses at the same time, okay? If I can point them out, this person, all right, this is Maria and David, have both hat and glasses at the same time, okay? Reina only have hat, no glasses, which is the one in black. John has nothing, which is the guy with the red shirt. So he doesn't have any hat, doesn't have any glasses, okay? So sometimes you can stumble in front of a graph just like this, okay? You might not see the picture, but you can have something like this to work on it, okay? So if I ask you the following question, what is the probability of, find the probability of H and G? H stands for hat and G stands for glasses. Notice that we have a total of N people, which is about 6 people, if you count them, right? That's 6 people in the picture. So my N will be 6. So if I say probability of H and G, so what do you think it will be? The one on top, how many H and G do we have? How many people wear hat and glass at the same time?
2.
2 people. Thank you very much. So you're going to have 2 people wearing glasses and hat at the same time. Therefore, that's going to be 1/3. Okay? And also you can do, if I say, for example, probability of, let me just do it because I don't want to run over what I'm supposed to write over here. So if I see, can do right here. If I say probability of H or G. So what I think this will be? H or G. What you can, the first thing you can do is against out of 6. Okay. Then you can just count the people if you want to. You're gonna say this is 1, 2, 3, 4, 5. That means it's 5 out of 6. If you count them together, that's mean this is how it happens. Or you can use the formula P of H or G. You're gonna say P of H plus P of G. Wow, that didn't happen again. P of H plus P of G, take away P of H and G. Okay? So P of H, how many people wearing hats? You can say this is 3. Let's put out of 6. If how many people wear hats? It's 3 people only wearing hats. How many people only got glasses? Notice that it's only 4 people wearing glasses. How many people only wear, how many people wear both hat and glasses? It's only 2 people wearing both of them. Notice that if you do 7 take away 2, I put a 3 there by mistake. So let me just fix it. So that to be 6 right here. Then that'll be 3 plus 4 is 7. 7 take away 2, that's gonna give you 5 out of 6. I know this is visual. You can figure out whenever, but sometimes you won't be able to. Okay, the next step I'm gonna talk will show you what I'm talking about. Okay, but let's look at this one first. So a Venn diagram is a chart that organizes outcomes. Okay, so suppose a probability of a hat and glasses, you just did that. It's gonna be 2 out of 6 that you can simplify to give you 1/3. Okay, 1/3. Okay, we did that one. If I say probability of no hat, that's we're gonna probability of 1 take away P of hat. Okay, so how many people wear hat? It's just 3 people out of 6 are wearing hat. So I would say 1 take away 3 out of 6. So how did they get 1/2? Let's do that together. And whenever you have 1 take away, just how if it's a reminder for people who didn't do math for a long time. So if you do 1 minus 3 out of 6. So what you do, you're gonna put this one out of 1. Okay, gonna say 6 times 1 is 6. Then 6 times 1 over here. Then minus 3 times 6. I'm sorry, 1 times 3. That's gonna give you 6 minus 3 over 6. That's gonna give you 2 out of 6. We simplify to give you 1/3, 1 over 2. So what did I do that part for? This is what the system I just did. If you have A over B, this is a review from 1033 minus C over D. This is to associate them, we're gonna say this is gonna be AD minus, that's AD multiplication minus CB divided by B times D. Okay, the one that have any 10 underneath, so I can freely put any number that you have that has nothing inside. You can always put on 1 underneath of it. Now the next step I'm going to talk about. Any questions? No questions. So next question I'm going to talk about is this one right here. As you can see, this is like a table, but it suppose has a probability of male or car. The story you must use the formula. Okay, you must use the formula. Now let's do the first one. So what is the probability to take the bus? We have a total case of 278 right here. Okay, so if you try to understand the table, so if you look at the table carefully, it means 75 men are taking cars, 14 men are taking a bike, etc. And then about the female one, 90 females are taking cars, etc. And 32 are taking bus. So if I were to know the probability of taking the bus, so what I think it will be? Probability to take the bus will be 1. Remember, the total here is 278. Okay, so what I gotta say? So what will you say? How many was probability to take a bus? Here we don't care about we don't care about whether it's male or female. We just want to know how many people are taking the bus. Can you see, look at the picture? How many people are taking the bus? You got 23 males are taking the bus. You have 32 females that are taking the bus. So how many people are taking the bus? 55. But this case can say 55 out of 72 to 78. Okay. And then this can be expressed into fraction, decimal, or percentage. Okay. There's another one. So here we're talking about how many males are taking a bike. You're a male and you take a bike at the same time. Again, this is out of 278. So how many males who took the bike? How many males are taking the bike? 14. Thank you. So 14 out of 278. This one is you got a factor on it. You can simplify it. So I'm not gonna do it now. Okay. So you can just simplify this one. So we can skip this one a little bit. So you guys try to get the idea. But the next one is very interesting. This one say you're female or walk to class. So this is a little bit different. We can say this one say let's put F for female to do the thing. That's mean P of F plus or W. That's mean that's going to be P of F plus P of W. Take away P of F and W. So now we need to know how many females do we have in total. Notice that we have about 154 females. 154 females out of 278. How many people walk to school, to class? Is about 37. See, right here and then there. Okay, so this is for walk, and the other one is for females. That'll be 37 right here. Okay, and then you can divide everybody divided by 278. 278. And how many female are taking the bus? I'm sorry, how many female are working? So notice also how many female that are working. Notice about 25 females do work. That'll be 25 over here. And then the math becomes simple right here. Okay, you do 154 out of 278 plus 37 out of 70 the same way. And then that'll give you 166 out of 278. This also can be simplified. So you're gonna skip it there. For now, you can just work it out. Okay. So I'm gonna have to stop here. And then I'm gonna talk about if you have any question about the exam, anything, if you are upset about it, something like that. And then I'll be happy to talk to you in private, not in group. Okay, so usually when I do it in group, I'm gonna lose control of the class. So we're gonna do that in private. If you have any questions.